So for example number 2, we're going to jump straight into plugging in an expression because that's where we're really going to spend the most of our time with Algebra 3. That's where, most of the work comes from. So this time we have g of x. So function g using the variable x is 2x squared plus 8x. So we have a quadratic, and we're going to be plugging in 4x to the third. So everywhere there's an x, we're going to put 4x to the third. So we're going to put it in both places. So we're evaluating g of 4x to the third. X is being replaced with 4x to the third. Again, I don't do anything with this. You hardly ever do anything with the left-hand side. So 2 parentheses. Anytime there's squared, we need parentheses. So let's actually, y'all know I love my templates here, so let's do our template. Everywhere there's an x, I'll put a parenthesis. So 4x to the third goes there, 4x to the third goes there. Now I've got some simplifying to do. I can't type this in the calculator because it does have a variable. So let's work on simplifying this first one because this is the hardest one. So exponents before multiplication, so we're going to simplify 4x to the third squared. Now there's a couple ways we can do this, but think back to Algebra 1. So we can cover up the variable and do 4 squared and then multiply the exponents, or we know anything squared just means times itself. So that squared right there just means 4x to the third times 4x to the third. So 4 times 4 is 16. 3 plus 3 is 6. So 4 squared is 16. 3, 2 times is 6. Okay. So I'm now going to replace that with 16x to the 6th. And I'm going to leave the 4x to the third. I'm going to leave this for just a second. Now I've got just multiplication. So 2 times 16 is 32, x to the 6th power. 8 times 4 is 32, x to the 3rd power. And again, the left-hand side I can't do anything with, so I just keep bringing it down. These are not like terms, so they cannot be combined any farther because this one is an x to the 6th and this one is an x to the 3rd. So actually when I get to this line right here, that's as far as I can take it. Since they're not like terms, I can't actually add those. So in terms of your final answer, we would stop right there.